Okay, this question is a three-dimensional question that might involve some Pythagoras and probably some trigonometry. We've got this diagonal to try and find. It's called the space diagonal OG, and you can see that that's going to involve finding this length first of all, because if you can see a right angle triangle there, where we need our length OB before we can find that length OG. So we need to think of a way of finding the length OB, and if you look carefully you can see there's another right angle triangle lying on the base of the cuboid with a side 8, a side 10 and OB being the longer side of the right angle triangle. So I would suggest first of all drawing that triangle where this is O, this is A and this is B, and you can see that OA is 10, AB is 8 and this side OB is found using Pythagoras. So Pythagoras states that OB squared is equal to 8 squared plus 10 squared. So OB is equal to the square root of that, and we get an answer for OB to be 12.8 rounded to three significant figures. So that's the length of OB. Now if you look carefully then you'll see once we know what OB is we'll be able to work out what OG is by again drawing a little right angle triangle. Now this time we know that OB is 12.8, so it might make sense to write that into our diagram. That's our 12.8. So 12.8 is one of the sides of the triangle, 7 is the other, so 12.8 and 7, and we're going to find our hypotenuse. So you can see that using Pythagoras again we get an answer of 14.6, again rounded to the nearest three significant figures, rounded to three significant figures really I should say. So at that point then we're ready to go on and look at part B, and part B says calculate the size of the angle GOA between the lines OA and OG. So using this blue pen I'm just going to look at what we're trying to find. We're trying to find the size of the angle GOA between the lines OA, so between this line OA and this line OG. So you should be able to see that we're looking at a triangle that is lying sloped in this shape. So it's sort of sloping up from this edge up through the centre of the cuboid up to this vertex G. So if we think about the fact again we have a right angle triangle, so we've got this right angle triangle where this is O, this is A, our right angle, and this is G up here. What do we know? We know that OA is 10. We don't know what AG is, but we know what OG is, and we've just worked out that OG is 14.6. And that gives us enough information to be able to work out this angle that we've been asked, which is the angle lying in here. So this angle can be found by using basic trig. So marking on our triangle, this is our opposite, this is our adjacent, and this is our hypotenuse. So we're using adjacent over hypotenuse, which is the cos ratio. So if we write that down, that is cos of the angle. We'll just call it angle O. I know that's maybe a bit confusing, but cos of the angle O is adjacent 10 over hypotenuse 14.6. So to find the angle, it's the inverse cos of that little fraction. So we'll do that now. And that gives us an answer of 46.769, so 46.8 degrees rounded to three significant figures. And just while we're explaining that, sometimes you do have to find the angle that lies between two lines, but sometimes you have to find the angle that lies between a line and a plane or a base. And it's a very similar question, but actually if you had to find an angle that lies between this line and the plane, you are finding a slightly different angle in this one, which is actually an angle that lies on this slope plane. So I'll maybe do another one like that again another time. Alright, hope this helped.